Link. 908, smallest range 1. Given an array A of integers, for each integer A sub I, we may choose any x with x between negative k and add x to A sub I. After this process, we have some array B. Return the smallest possible difference between the maximum value of B and the minimum value of B. Okay, I feel like I read the problem aloud, but I didn't really actually understand it. Okay, so you have an array, and then you have some x. So we could choose any k or negative k to add x to it. Okay. Between the maximum, return the smallest the maximum. Okay. Oh, so each number could be each number could individually be choose a different k. Okay. So given k, yeah, I mean, I think with this one, I would take the smallest number and then add k, and then every other number just try to get as close to it as possible. I think that's all. And even though there may be a more quote unquote optimal case where k doesn't have, or for the first element doesn't have to be, you don't have to use all of k for the first element, or the smallest element in this case. You can always add less than k on sequential elements. So I think that's what I'm going to do. Cool. Return the smallest possible difference. Okay, so we don't actually have to return the array, so that makes it easier in the sense that now we could just sort the array, the input, because then allow us to do what we said about the smallest element. Because if you need to return b, then you have to kind of keep track in a different way. And really, we don't even actually need to sort. We could just do a linear scan for minimum. But if I'm trying to optimize for time, then this allows me to get the smallest element and also allows me to iterate on it, because in theory there may be, like, I mean, this problem maybe is not that complicated, but in theory there may be other things where yeah, like it may get a little trickier, and like there's a part 2 or something. Let's say target is the first item plus k. It's items. Okay, and I'm just checking that A has at least one element, because otherwise this would just give you an error. Definitely have got bitten by that before. And also, obviously, if you're in an interview, then you would talk about how, you know, like, hey, should I add, like, you know, bound checking and stuff like this? And depending on the interviewer, sometimes they don't need you to, sometimes they do. So that's why it's always good to ask. It takes about 5 seconds to ask, and like too long to write on the whiteboard, because I don't know about y'all, but on the whiteboard it's kind of way tougher than on the keyboard, especially on my wrist. Maybe I need to work out more, because I think the last time I did something, my my arm got a little tired because I was writing a lot the entire day. But anyway, but yeah, and then now we can just go for each item. A and A, that's a little bit, let's say number in A. So let's see. So okay. So yeah, so the best is equal to, say, max 0, because we can only go higher. And then best is equal to the max, because so your worst case is going to be the maximum of this, which is your previous best, or the absolute value of num minus target, kind of, but it's missing the k, minus k. Right? Something like that, maybe. Oop, did I miss a thingy? I missed a... I feel like sometimes it auto closes my parent, sometimes it doesn't, and I get a little confused. But yeah, and now this is, given competitive programming, I would try to, I've been actually really bad at testing. So now I'm trying to be a little bit more deliberate because it's not that usually my algorithms are right, but I'm missing like very silly edge cases. But yeah, hmm. I think this is a little wrong. So because if oh no, because we want it to be, so we don't want the absolute value. Okay, we actually want it to be. That's right. We want either min or max of 0 or something like that. The idea is that yeah, max of this and 0, though maybe it doesn't matter. The idea is that if you use only one, or maybe this minus k actually, I think it's the other way. The idea is that you could use up to k of them, but so if the difference is less than k, then you're good. If it's more than k, then you have to keep track of how much you're going over. Okay, yeah, I mean it's also worth kind of testing the assumptions, I guess. But cool. A little bit slower, but maybe on the sorting. I don't know what the input sizes are actually. I didn't look for this form. A is only 10,000, so it's not that bad. Not sure why this is slower than whatever, but you could actually do it without the sorting if you just do another for loop to get the minimum value. Which, I mean, depends on what you're doing for. Obviously, for an interview, then you actually want to do that because then when you talk about complexity, you'll be like, oh, this is all of n and all of one space, or one extra space. But for me, at least for now, for different mindsets, I suppose. For competitive programming, obviously, I'm minimizing my typing, and I do the least. I would trade off certain constants for typing speed and just accuracy, because this sorting and then look at the first element is pretty hard to get wrong. Though I mean, I've gotten it wrong before, obviously, but it's still harder to get wrong than like running a for loop. So you have to do that calculus in your head. But in general, yeah, in general, this is a easy problem. I don't know if I would expect this to be on an interview, but it is straightforward. So maybe for a phone screen or something like that. I don't know why there's so many downloads. This is pretty. I don't know. I don't know if there are any weird edge cases that I hadn't considered. The examples are pretty detailed, so I feel like that's okay.